So, we're now ready to build up this section of our waterfall. So, here on this cash flow waterfall schedule, we have the levered free cash flow. We want to account for deposits to pay back capital, the cost to fund, which will lead us to the levered free cash flow to the equity holders. So, for the cost to fund, deposits to pay back capital, as it is in our regular non-project financial model, we will say that this cost to fund and deposits to pay back capital could refer to our net earnings. So we are saying that this is the cash flow generating from operations. Then we're gonna deduct debt or whatever we have to pay back this loan. We're gonna take that amount to arrive at what free cash flow will be available for the equity holders. So that's exactly what we are saying in this model. So basically, we are saying that the free cash flow takes into account the cost of debt, the cash flow available to pay down the debt, then we arrive at whatever is left for the equity investors. So to begin that, we're gonna do is we will just reference to our schedule, the development cost, to grab the cost to fund. In this case, approximately 14 million in the first year, and the process to pay back capital. We have that amount there, and the loan draws, which we had 5 million available for the loan acquisition. And then we have the loan repayments over here. So what we want to do is we want to take the sum of all of those things. So the value here going forward in negative is the value available to be funded by our limited and general partners. So this is what they bring in as initial capital into this project. So this total amount, 9.6 million, is the peak equity that will be injected into this project. And going forward, we can see the cash flows that will be distributed as a result to these partners. So this is a joint venture partnership where the limited and the general partners come together and bring in this cash flow going forward. So this is what will be available for distributions at every tier to both the general and limited partners based on their contribution amount. So we're gonna be seeing that more in the cash flow waterfall. For now, we want to calculate the levered internal rate of returns. So in this case, it's gonna be based on the levered free cash flow. So we're gonna use the XIR formula in Excel. But before we do that, we want to calculate the equity balance. In this case, it's just the prior period, and then we add the current period balance. We take this all the way to the right. we fill it with Control R. So this is where we're gonna get our peak equity later on. So now we wanna determine the levered internal rate of return. So it's gonna be XIR, and then we take all of these cash flows, the levered free cash flow, and we discounted this. We are actually so we take all of those cash flows and the date. So we are actually bringing this value back to the transaction closing date to determine what the internal rate of returns will be. So having that said, you can now hit enter. As you can see, for this entire project, hit a rate of return of 33%. So this is because we have debt which has been injected into this project. So remember that the maximum loan amount is approximately $19 million. And going forward, we can see that that amount has enhanced equity value to about 33%. So let us look at this amount. Let us calculate the unlevered internal rate of returns. I could just write it here. Unlevered. So this is the rate of return that doesn't take into account the debt that was injected into this project. So say this debt was 100% financed by equity. So we're gonna go by taking the sum of the cost to fund plus the proceeds to pay back capital only. So we're saying that they are financing this project using equity only.